Oh, no, we don't want to do that. Has everybody seen the note well yet? Anybody not see the note well yet? I didn't think so. All right. So we have a pretty packed agenda today with lots of excitement, discussing some working group documents, going through some errata, and then a couple of new items, including some discussion about rechartering for some additional items. So does anybody have any changes to the agenda that they anticipate? Okay. Then let's get going. So we have a couple documents that have been going through the working group process. One of them is EAP TLS 1.3. I think John Matson is online, and if he wants to come up and present, he can do that. Do you want to?
So maybe I can quickly go through what has changed in the latest version, what were the comments we received in the last call, and what steps do we plan to take about it. So basically, we agreed that we'll remove all the text on other TLS-based EAP methods. So there are now he's.
Hi. Do you hear me? Yeah.
We can hear you.
Great. I just didn't know how to enter presentation mode. So yeah, we removed all text about other TLS-based method according to the decision last meeting. This should move to a separate draft, probably draft DCOC EMU TLS EEP types that will be discussed later. We added reference to draft IETF TLS old versions. This is a draft in the TLS working group that is updating RFC 5216 and prohibits use and negotiation of TLS 1.0 and TLS 1.1. So this the TLS 103 draft now reference that and describes this update. Also slightly changed the language in the text to not refer to TLS 102 or earlier, as they are or soon will be forbidden to negotiate in any use of TLS. Then there's a new section on hello retry request. That's very straightforward. It just describes this new hello retry request message that TLS 103 introduces, so nobody is surprised. Then there are several changes based on the review by Jim Schad. I think there's nothing major. There's some editorial rewordings, and then there are some technical rewordings changing from what not to do to instead what to do. And then there are updated requirements on the LBIT as suggested by Oleg. And what was decided was to decide what to do, but to be flexible in what clients and servers accept.
Thanks.
And this draft went through working group last call without any comments, but after the working group last call, there was comment by Joni Malinen. And the comments were, the comments were about the use of the empty TLS record. As you could see on the last slide, the TLS 103 allows you to send this in two different ways, either with the problems here is that OpenSSL does not support everything in TLS 103. It does not support you to send a completely empty TLS record. And it does not currently support the server sending early application data without the client first has sent an extension. So this needs to be solved somehow. And also, I think we can go to the next slide. And then Joni also had more editorial comments that needs to be changed, that the language, it's not really empty, and we should change it to a better technical description, and also that there's slightly different wording in the text and the figures that should be fixed. But there are two problems that we need to take decisions on, and Joni and Alan had quite good discussion on the list. So the first problem is that OpenSSL 1.1.1 does not support an empty string to be sent as application data. Joni suggests to use 1 byte with zeros instead. And I think Alan agreed that was a good. And there is, what needs to be decided here in the group is, do we go with this approach, and then do we go with a single solution, or do we allow the client or the server to send different things, and also how should the client react if the server sends something unexpected? Should it ignore it, or so? I think it would be, the wording discussion on the list was to maybe allow both. I think it would be good to have it as strict as possible. Maybe I would suggest going for 0x00 only, describe that is what you shall do, but then maybe write that you accept anything else also. I'm hesitant to talk about this as a future extension mechanism. Any comments on this?
So, Mohit, I agree we should be as strict as possible, but also define how the implementation should behave when things don't go as expected. So sending 1 byte of zeros is fine. Anything else? I think there was some comment on the list saying that perhaps that could indicate that there is other post handshake messages that the server is trying to send. I think it makes the implementation more complex, because now you're in this state that there may be more messages coming. So I would prefer to keep this more strict and just say that once you're done, send this 1 byte of zeros to say that, okay, that's the end of the handshake.
So we will try to update the draft with this. If you have any further comments, send them on the list as soon as possible. Then the second problem we need to discuss is that OpenSSL does not support the server to send early application data to an unauthenticated client unless the client has sent the early data extension and the client has sent early data, if I understand the comments on the list. Fortunately, this can be, we don't really know if OpenSSL will support change its behavior in the future and support this feature in TLS 103 or not. But you can get around this by forcing the server to send a new session ticket. So we don't really need any changes to the specification. Should we document this in some way? Yes, some short note somewhere that if at the time of writing this draft, some implementation does not support this, and then it can be solved by forcing a new session ticket or some other post handshake message.
Jim Schott. I don't like the idea of sending a new session ticket because the server may not actually want to send a session ticket. I also don't understand why you think this is a problem, because in the OpenSSL case, they can send this message after the client authenticates. They just have to send a data record which says, "I'm done. We're not going to do anything more." It doesn't matter whether it comes before or after the client authenticates.
But the IETF 1.3 documentation right now says that you must, if you don't sending any post handshake, you must send an empty application data to let the client know the EAP state it should be in.
Correct. But it does not have to send that message before the client authentication messages come. It can send that afterwards.
Then it becomes...
It's just the first authenticated message from the server to the client. It doesn't matter where in the sequence it comes.
Then we need to, if to allow that, we need to rewrite the specification. I don't know how that match with the EAP state machine. Maybe it works.
I mean, it should match just fine, because you would send that message instead of sending the new session ticket.
Yeah. Yes. Okay, that sounds good.
Okay, is that something we can clarify on the list?
Yeah, I think so. But that seems to work. Then we make it optional when the client, the server sends this application data to signal it will not send any more handshake. In current version of OpenSSL, it will still introduce an additional round trip, but the server does not need to send a new session ticket. That seems good. Yeah, I agree. I will send to the list a summary. I will try to write it down and then send it to the list to confirm this and get more discussion.
Great. So I think, once we get that settled, I think we can either see if we need to do another working group last call, but probably we can just make the revisions, and as long as we don't have any contention, we can move forward.
Yeah, sounds good.
All right. So here's the other draft is yours too, John. So I'm going to leave you in the queue.
Yeah. So we have submitted the new version with some comments and changed packets to round trips. So authenticators typically end the connection after 40 to 50 round trips, not package, as was stated in the earlier version. We have added short text about other TLS-based EAP methods in the introduction. We earlier took the decision to change the title to other TLS-based EAP methods, and now that's reflected in the introduction. Then there is a new section 424 about suppressing intermediate certificate. This shortly describes a new TLS working group draft by Martin Thompson that allows the client to inform the TLS server that it has all the intermediate certificate and that the server therefore can omit sending any intermediate certificates, therefore reducing the size of the TLS handshake. Then we have added text to section 4.3 about updating authenticators. This section existed, but it was empty. And this basically describes the reasons why authenticators might want to limit the amount of round trips packets, and also shortly why updating existing authenticators is hard. And this text is quite a lot up based on the comments, explanation by Joni, I think over a year ago on the mailing list and the formation of the EMU. And that's basically it. I think it's in a good shape, quite good shape now. All the comments received have been addressed, as far as I know.
It's definitely my action item to call for the adoption. So I'll do that immediately after this meeting. And unless there's somebody who objects. Here. Okay, perfect. Okay. All right. Yep. Okay. EAP session ID.
Not a lot new since the previous draft. Just restating. Sorry?
Bernard in the queue. I don't know if he's for the previous.
Oh, no.
Bernard, you're popped up in the queue, or we didn't see you before?
Well, I was commenting on something like a half an hour ago. Not relating to this.
Okay, well, we'll put you back in after this if you have. Do you?
Sure.
Is this, okay.
Okay. So session ID, this problem statement hasn't been defined for fast reauthentication. Likely vendor EAP methods have the same problem. I tried pinging some people, haven't got response, so I suspect most of the vendor EAP methods are dead at this point. The draft has minor changes from 0.0, updates to EAP sim, noting that there may be a varying number of triplets. And other than that, there hasn't really been much in the way of comments or negative feedback, but I'll wait.
I think we should adopt and do last call as soon as possible. I had one other comment. Can we change the title? Because now it says session ID derivation for EAP and not like, can we make it a little bit more specific? Because otherwise it feels like this draft defines how to derive session ID for all EAP methods.
Sure.
Mohit.
I think that's it. No
Okay,
questions?
so we'll start the call for adoption after this meeting. Do we want to, Bernard, did you want to come to the mic? All right, I don't see him. All right, we'll go to the next. So we have also have another draft that's waiting for adoption and that has gotten some support, but there were IPR issues raised against EAP, aka PFS. So we had some discussion on the list a while back, beginning of this year, but no other alternatives have been proposed for this work item. In general, there is consensus that this document is needed and should move forward. In addition, this IPR situation isn't any different than what's for essentially AKA and AKA prime, and the document is targeted for an informational document. So my proposal is that we accept this as a working group item, unless there's people are wanting to object. Anybody here wishing to object?
Roman Danili was the responsible AD. Not objecting. I just didn't watch the process. When we did the call for adoption, did we explicitly kind of call out the IPR issues?
Yeah.
Yes.
Yeah.
Perfect.
Okay. Yari, did you have some slides, I believe?
So I had slides on the other one, not the PFS.
Right. Yeah. This is RFC 5448 bis.
Okay, so just real quick. So this has gone through working group last call, and there's been some feedback from that, as well as feedback from various IETF and 3GPP participants, and as well as and importantly, implementer feedback. And so we published a new version before the deadlines, and that new version has a few sort of relatively minor changes. We had in the security considerations text, we mistakenly had said that must not communicate the privacy-friendly identifier and must communicate the permanent identity of the user, and that, of course, it was exactly the other way around. Fortunately, that was said the correct way elsewhere in the document, not in the security considerations part, so we changed that. That's a big bug, but hopefully people understood the other parts. We also changed, because we were sort of carefully going through the 3GPP specifications and the IETF specifications, and then there's some cases for like what do you need to do in when you receive different types of identifier requests in a 5G network, and the 3GPP language talked about you shall do this and that, and our previous text was should do. We changed it to a must to match better the 3GPP language. We also added an attribute table, and we've not had an attribute table, so a table of attributes where they must appear, or what attributes can and may appear in different messages, and that did not exist for 5448 before. It did exist for 4187. So we took that, added the entries that belong to EAP, aka prime, just to be sort of crystal clear, what's needed and what's not. So there's actually two attribute tables depending on the situation that you're in, and yeah, that's at least I personally felt that that's useful. There were some attacks, of course. I mean, the AKA protocol receives quite a lot of interest from the academic community. So different types of security problems or potential problems are looked at over time, and a couple more attacks have been discussed now in the security consideration sections, including what the impact or lack thereof might be. So do take a look at that. Then some more really minor things. We just made absolutely sure that we say what to do with the length field calculations, so we say things more explicitly now. We clarified a little bit the language around the AT-KDF negotiation procedure, as well as what to do in the case of the synchronization failure messages and the AT-KDF attribute. And then a hugely controversial change, I'm sure, we moved from decimal to hexadecimal for the EAP type values, just to make sure that different documents are in line with each other. and then some reference updates and editorial clarification. So that's basically it. If people have any particular points to raise here about these changes or other things, we can have some discussion. I don't think these require any sort of reprocess in the working group. So from my perspective, the next step is the chair should send a PUB request to ISG, and then that process should start. Yeah, that's it.
Any comments on this in the working group? Anybody not think this is ready for ISG? Okay, thanks.
Thank you.
No, so Daniel Migo, I was saying, yeah, the document seems ready to me.
Yeah, I just have one question, which is who's reviewed the document at this point for that particular question? Sorry, Elliot.
How many people have reviewed the document? Yeah, 2, 3, 4, 5.
And also outside this room, we had a fair bit of the Ericsson team looking at this, as well as various people from 3GPP, other companies.
Okay, so there's been some review of the document. Thanks, Elliot.
Thank you.
Is that what's next? Let's see. All right. So next on the agenda is Uni has been busy working on a TEEP implementation, apparently, and he filed some errata against the TEEP RFC. So there were some existing errata already there. These two that I have on here. What I want to try to do is go through some of these here and see if anybody has any opinions on them. I have a feeling that some of them will need to take to the list to continue. We'll continue discussion on the list because they're a little bit complicated. But these first errata seem pretty straightforward in that the function signature for the TLS PRF was represented incorrectly. And so these are just pretty straightforward changes that were reported. These were reported a while ago. So my proposal is to accept these changes. I believe it's just a kind of a mistake in the function signature. So I already posted this to the list. If somebody could take a look and make sure that that this looks correct and respond, that would be great. And then we believe the process is to tell Roman, and then he can do whatever magic it takes. Yeah. Did I cover which? Yes. Sorry. And so there was no objection to adopting the document. So, yeah. The next errata was one filed by Uni. There's some conflict between the authority ID, which is an outer TLV in TEEP, was currently marked as being mandatory. But there's another section of the document that said all outer TLVs must be optional. This seems like a pretty straightforward change to make the authority ID optional. So unless somebody does anybody have an opinion on that in this room?
I just have a question, which is is there any logic as to why it was a must in the first place? Sorry, Elliot again. Yeah,
that's a good question. I don't know for certain. I think it was EAP Fast has a similar construct, and it may have been marked mandatory in EFAST. This is something we'll continue the discussion on the list. I just want to see if there's any discussion to be had here.
Mohit, I assume there is text on what to do when some TLVs are not there. So what should an implementation do when these optional things are not there? I haven't read the full spec myself, so.
We're right in the middle of doing the implementation right now for
Okay.
TEEP, and so a little bit of time on this, unless there's a rush to do it, we can verify it as we're going through our implementation.
Yeah, that would be awesome. So yeah, with all of these, this is something, if you guys, when you get to this point in your implementation, it'd be great to get the comments out on the list. Thanks. So similarly, there was some confusion as to the intermediate result TLV, and Yoni proposed a clarification in the wording here, and clarifying what the authentication method text, how we define an authentication method versus a non-authenticating method. So EAP identity versus a method that performs an authentication. I think this is pretty straightforward. My proposal would be to accept, but if there are people implementing at this time, I'd like to, we can certainly hold off until the implementers come back.
I mean, if we're going to be waiting, Roman Danilo, if we're going to be waiting for the last one based on implementation, I see no reason why we couldn't just batch the couple of them waiting. But we should set a date that we would go forward, even if we don't hear from the implementers.
Okay, yeah, we'll work with that off list and see what the schedules are. But because it is pretty important to move forward, because I know Uni is waiting on his implementation. So if we can kind of try to get these questions resolved, that would be helpful. The next one is the compound MAC is specified as 20 bytes, which is kind of fixed to the length of SHA-1. SHA-1 is no longer used by most TLS cipher suites, so we need to decide what to do here. It could either be, I think Yoni said his simple fix was just to truncate the max to 20 bytes. It seems like maybe it would be better to have a variable length MAC. That would be my preference. This is something we can probably discuss, Elliot, if we can work with your implementers to kind of work through this issue as to what seems to be the best. That would be great. The same thing. Roman?
No, Roman Danilo again, with kind of all these, my question is, do we want to put a timer on trying to get a response?
Yeah, absolutely. I mean, so my guy's got to finish this pretty much by the end of the summer. So, I mean, I would say end of the, it's September 1, September 15. You want to just resolve by that timeout, that's fine.
I was just thinking before Singapore.
Yeah. We definitely want to have these resolved by Singapore.
Yeah. All right. Let's take that offline.
And then there were some questions about the kind of session key derivation. This is kind of very vague in the draft because there are implementations that may support an MSK and an extended MSK. So this and the instructions on how to construct the secret aren't complete. So there's a lot of questions as to how it should be done. I think this can be this needs to be it can be worked through, but it needs to be clarified in the draft how it works. And then finally, what to do if there is no key generating method executed. The draft does not specify what the compound MAC key is in that case, what CMK 0. And so presumably there's a couple options here, but we just need to decide which one it is and then do that. So the changes here are significant in that they do affect interoperability and implementations, and so we'd like to get these resolved, and then we can certainly file the errata. Then the question would be is if we want to open up the RFC 7172, see if we want to make a revision to fix these. But I think we can wait on that.
So, yeah, one of the things that I think that ties to is our presentation a little bit in terms of IETF Brewski. One of the reasons that it does is that essentially IETF Brewski sort of set out to do what IETF was planning to do anyway. If we're going to open up that document, maybe we just cram our stuff into that then, but otherwise we just do it as IETF extensions. And I'm sort of easy as to how we go about that, right? If whatever the working group wants. I think the real question is whether people want to do the implementation along with us on the IETF Brewski stuff, and at the base level. Oh, and there's more to it. Maybe that question you should defer until my presentation. Anyway.
Okay.
This is Alan. I just have a follow-up to that. I know my next document talks about fixing TEEP for TLS 1.3, but if it doesn't sort of mostly work for TLS 1.2 right now, I'd be more than happy to remove that text from the document, because honestly I have no idea what it should say, right? And there has been very little feedback. So I'm happy just to remove that, push it off to a TEEP bids or TEEP updates or something.
Okay. All right, so I think that anybody have any other discussion items for TEEP errata? All right, then we'll move on to. Oh yeah, we can do your.
Thank you. So hopefully this should be pretty simple. So again, key derivation has changed in TLS 1.3. Most of this is pretty easy. FAST and TEEP have a much more complex key derivation. So if we can punt on that specifically for TEEP, that makes this document pretty trivial. EAT FAST, I have fewer opinions on. That's mostly historical Cisco thing. I guess the question for Cisco, maybe Nancy or Elliot or someone else, is whether you have opinions on this and what should be done. Or perhaps there could be just a statement saying, yeah, don't use EAT FAST with TLS 1.3.
Elliot here. I don't have an opinion personally, but I'll take it back.
Thanks. So the short solution is there were some small changes to EAT TLS key derivations, and now unlike the previous EAT methods in TLS 1.2, all the key derivation is the same for all the TLS-based EAT methods, with the exception of the other ones. So that just makes things much, much simpler for implementers. Not really a lot of security considerations. Lots of issues with EAP and TLS, but some minor ones that need discussing here. And as the question, is TEEP errata. I think I'm happy to pull that out and push it off onto a TEEP document because it looks like suddenly everyone's implementing it and discovering all kinds of issues with it. And so we can simplify this document. So if we pull the TEEP and maybe have a simple comment for fast, then this document becomes very, very trivial. And we should be able to publish it pretty quickly. Questions? No? All right.
All right, so now we'll move on to our rechartering discussion.
Sure. So over the last couple of IETFs, we have had several new drafts which aren't necessarily covered by the existing charter. So the draft that Alan presented just now, it's somewhat covered, but it would be nice to clarify the charter text further. As you saw, we discussed several EEP-TEEP erratas, and perhaps it would make sense to open that document and fix those things, especially if people are implementing it. So perhaps including that on the charter would make sense. Also, we have had like a couple of drafts which are completely out of the current charter. So one has been this OOB authentication for EEP, which is just draft Aura EEP noob, and then also a couple of drafts that try to do things where you start with certain credentials and then you end with certain other types of credentials. So let's say you start with certificates that are put by one guy, and then after you run EEP authentication, you end up with certificates that belong to a different domain, for example. And there have been requests to update the charter, and I guess we are using this time to discuss if there is enough interest, if there are enough people willing to review the text, what should the charter exactly cover, and so on. So this charter text is a revision of the existing charter, so it still includes all the things that we have currently on the charter, including EEP TLS with TLS 1.3, EEP aka PFS. I polished the text a little bit and fixed some typos, but otherwise all the 3 paragraphs on this slide cover what we already have on the charter and not necessarily any of the new items. Do you have any issues? If anyone has issues with this text, come forward now.
Can we ask how many people have read it?
Yari has read it because he wrote the initial charter.
I have also misread it.
I have an additional EEP-related question, but perhaps it can wait till after this. It is unfortunately timely and a little bizarre, unless you want me to talk about it now.
Is it related to our charter discussions, or do you want it on the charter? Is it something?
It's a question of what do we do? So there are people doing things with EEP that violate the existing RFCs and are pushing them out all over the place. And what do we do when things bypass the IETF and don't get review and?
Is any of these items are violating the?
No. This is something in addition to the charter.
Right.
But it's
sure.
something that we may want to have an opinion on.
Yeah, we can have a discussion on that.
So I don't know enough about the specifics of that issue, but is the concrete action that you're proposing for us is a publication of some implementation guidance?
It's more just asking, what do we do about it, right? I mean, allegedly, if the IETF is in change control for EEP, and people are implementing things and vaguely sort of standardizing them that violate the various RFCs and do some inventive things without review. The question is, what can we do? What should we do?
Okay. Yeah, that's that.
I was going to say that doesn't sound like a chartering of a new item.
Bernard's here, so let's
hear him.
Well, I mean, there's no e-police to call to have those individuals arrested. Presumably, you know, if it was a security-related thing, if they were doing something bad, then people could, you know, it wouldn't make NIST guidance, for example, or people might decide not to buy it. Are you referring to security things, Alan, in particular?
No, so as background, there was some work in 3GPP on encrypted MCs in SIM and AK and AKA prime. That work is now continuing, partly outside 3GPP, from what I understand, and doing things that are not really clear. It's not clear overall, even to me, why this kind of thing is happening. And then the question, I guess, is, do we have a charter item to work with people to get review before these things get standardized outside the IETF?
Yeah.
Or what?
So we have the EAP method number, right? INR allocates them, and there is expert review for doing that. And there is no requirement that all the EAP methods are published as RFCs. Last I counted, there were 52 EAP methods. Perhaps that's some we could provide some guidance to the experts that when they are doing the method allocation.
No, it's not.
No, that's not right. I don't think. It's the vendor stuff that doesn't have to be reviewed. To get a method allocation, you do need review.
This is not vendor stuff. This is changes to existing EAP methods.
Oh, okay.
Darshak Thakur, Cable Labs. So I guess the question is, are these people even going, if we actually recharter or do something, are these people going to bring any of this to the EMU working group to review? If they don't, what are we going to do?
Yeah, I mean, so you would think people changing EAP methods under change control of the IETF would talk to the IETF, but apparently that doesn't always happen. And I guess the question is, do we want to see if we can reach out and review these things, or have a IETF statement, as Bernard said, about security practices, or this is good and this is bad? I don't know. It's all rather unclear right now, unfortunately.
We can reach out if we know about them. So I guess this is where like liaisons with 3GPP and so on can help us, but there's no way we can force people, you know, if we don't even know about it, we can't help them.
Roman later to reiterate, to go talk to people, we don't need to change the charter. If we're going to formally do something in terms of producing a draft, we certainly would need to. And we've already said liaison statements. So if we don't have liaisons to the right organizations, we can absolutely find those.
So, all right, this was what this text covers what we already have on the charter, and then the next slide we had some text on things that have been brought to the IETF and are currently not on the charter. This is some initial text, and now it's open for you to come and bash this text together. So if you have comments, what do you think? Does this make sense? Does it cover the things or the ideas that you had in mind?
If the working group wants to kind of tackle some of those issues, I will support them. Editorially, I think we should structure those work items similarly to the way we structured the other work items, unless we're rewriting the text of them. Because all the rest of them are provided guidance or updates to update foo, and this one has more background than some of those other items. Was that explicit?
Well, the other items were kind of fixing existing things, whereas these would be either a new method or extensions to method, whereas all the previous were like how to do EAP-TLS with TLS 1.3, but EAP-TLS already existed. The same for EAP aka prime. Sure, perhaps this could also be restructured. There are no comments, and we are ready with the charter.
So does anybody have any concerns, or does this cover, Elliot, things that you guys are looking at?
Forgive me for not being able to really read through the text on the screen. It's really hard from back there. But in my earlier discussions with Mohit, where I thought I had it wrong, Mohit corrected me to say, no, I have it wrong. I do have it wrong. Here's where you're covered. I'm essentially trusting you guys that you've gotten it right. That what I'm expecting is that we'll be able to cover like either a TEEP update or EAP Brewski, or and certainly we'd want to also include in that something like EAP Noob. And I'm not saying, by the way, that this forces the working group to take on any of that work. Just that if we get into an adoption call, that it's ripe for when it's ripe for consideration, we don't get into charter issues.
For each of these items, it would be nice to kind of see who would be kind of working on them, who would be implementing.
You can ask.
Okay, so for the out of band, we can call these kind of out of band channel, I guess, introduction or registration methods. Are there people who are interested in working on this work item? 1, 2, 3, 4.
Yari, maybe.
I'm sure Thomas, who's okay. So we definitely have interest. And are those, how many of those people are willing to actually contribute text? Okay, great.
Clarification, I suspect, Daniel Migo, when you say adding text, you mean reviewing it?
Well, when I say adding text, I mean authoring. Okay, not necessarily, doesn't necessarily have to be a primary author, but we definitely need people to author the documents. And then instead of just reviewing and making comments, it's very useful to have people who will actually contribute the text that will fix the document.
Ditto on that, Roman Dinelli implementation, who's willing to write the code for it?
Okay.
So forgive my thickness, but just point of clarification here, Mohit again. Which sentences do you believe cover the sort of not only I can see where EAP Noob is covered in the QR code discussion.
Sure.
Where do you think that the EAP
The entire second paragraph. So the second last line, the reason it says minimal mechanisms is try to use existing things where it would be hopefully TEEP or some method that has a TLS outer tunnel. But because there is also this other draft which EAP cred, so I didn't want to tie it down to EAP TEEP, but the fact that it says minimal mechanisms with which limited use credentials can then be used for creating general use long-term credentials.
Okay, again, I think there's probably a little bit, look, I don't want to take up time in the meeting for this, but I think there's a bit of consistency between the language between the first and the second paragraphs, in which the first paragraph is quite
happy to receive changes, suggestions.
Right, so what I'm saying is the first paragraph is quite specific, the second paragraph is quite general, with the exception of the word minimal, and minimal is a little vague in terms of what it means. in this context, as you point out.
The reason is there is true drafts, so there is EAP creds, and I'm not authoring any of those two drafts. I'm just saying there were two drafts, and I tried to capture essentially what they're trying to do with the same text. But if you want to put TEEP here specifically, that's something we can discuss on the list as well.
Yeah, and I think this brings us back to both the previous conversation and the forthcoming conversation, is that it's clear that there is some TEEP work that's needed. In fact, one of the conversations I just had at lunch was from people in the field area network space, in which they're not even sure they want an outer TLS connection. We need to have that dialogue, I think, here in an aim towards common architecture. And so
in that case, this text is in fact better because I don't say TEEP, so you're not necessarily restricted by having an outer TLS tunnel, and rather you have minimal mechanism, so it's a broader swath.
Yeah, I'm actually thinking of the first paragraph, in which you name the drafts, and probably there's little reason to do that, is what I'm saying in the charter, in that part of the text, and that goes to Roman's point, right? Which is you might want to separate out that text in terms of the third line, stick that into your deliverables text or something like that.
Okay.
The Chicago Cable Lab. So I think you already covered the question I was going to ask, but I think the second paragraph is general enough, and I assume that it kind of already covered the EAP creds use case also, right? So I'm fine with it. We can probably do some word spinning, but overall, I think it's general enough.
+1 for the text.
Okay, I think we should still have some discussion of this charter text on the list, since not everybody's here, and I think it could probably use some polishing.
Sorry.
Yep.
In general, I think the text is good enough to go forward.
Okay.
Don't look at me as a hold up here.
Yes, but Roman, but yes, again, I think we still confirm on the list.
Yeah, absolutely. And just to confirm the second part, for the minimal mechanisms which use EAP authentication credentials that can be used for creating general use long-term credentials, are there people who are interested in working on this item? These 3, 4, 5, 6. Okay. How many interested in contributing text? Implementers? Okay. Great. All right. Yep. I think now we go back to the agenda. Let's see. Next, we have an update on EAP Noob. So, Thomas.
Yes, just can you hear me?
Yes.
Okay, so it's an update on EAP Noob. Next slide, please. So just this slide is a kind of segue to the rechartering discussion. So just a reminder that out of band means a second independent communication channel, which is used for authenticating something on the primary channel. And this has become a kind of common way of bootstrapping security in applications and devices. But EAP, even though it is this generic authentication framework with all kinds of authentication methods, doesn't currently support out-of-band authentication. And that's why we set out to specify the EAP Noob protocol for this purpose. Next slide. Here is our timeline. We have been working actually over 3 years on this, and kind of polished the specification, and then written implementation for Linux, and then modeling and verification of the protocol. And as a new thing, there is now peer implementation for Contiki in progress. And the draft is in version 6. Next slide, please. So I have kind of 2 slides just to remind us what is EAP-Noob, an overview. So it is an EAP method for bootstrapping devices out of the box without professional administration. That's kind of the use case that we're trying to solve. The authentication is based on user-assisted out-of-band authentication, such as the user using a mobile phone to scan a dynamic QR code or NFC tag. And in addition to doing just one-time authentication, the method registers the devices to AAA. It creates a persistent association between the AAA server and the device. And this association can then be used later for fast re-authentication of the previously registered devices. Next slide. Here is an architecture picture of the use case when this method is used for network attachment. So we have a new device that is not yet registered on the network, and then we have the network infrastructure with an access points and the AAA architecture. And most of the communication in this method happens over the EAP channel in band between the new device and the AAA server. But then there is one message that goes over the user-assisted out-of-band channel, such as the user scanning the QR code, but could be something else. And that authenticates the in-band key exchange and configuration. The trick here, that kind of critical thing, is that normally in device bootstrapping, you have the problem that you would like to register a device in the server, but you need network connectivity for that. But then you don't have network connectivity because the device is not yet registered. And we've solved that by using the EAP tunnel for communicating between the new device and the server before the device is registered. And clearly this has been a successful idea. It's been now copied by at least 2 other drafts. Next slide. What is new in this version? The draft has been fairly stable, so we have continuously just polished the text and the details of the specification based on feedback from implementation and lessons from the formal verification. However, this time we did make one slightly bigger change. So in earlier versions of the draft, we have overloaded the network access identifier NAI so that it conveyed the peer ID and the state, and this doesn't really comply with the EAP RFC's guidance, where it says that the identity response should be used primarily for routing and for selecting the EAP method. And for that reason, we now cleaned up the draft and got rid of this overload of the NAI, and the cost here is an extra round trip at the beginning of the EAP conversation. But it does help the implementations as well, because implementations are not really, don't have support for this changing the NAI frequently. So that's the only bigger change for a while. Then there is some of these smaller cleanups. We added earlier a key identifier to help the peer implementation. But after some thinking, we may want to in the future randomize the identifiers in the protocol for privacy reasons, and the key identifier would then leak the peer identity. So it's better get rid of that. The cost here is that the peer may sometimes, in rare cases, have to try 2 different keys because it doesn't know whether it's the new or old key that was used for some message. And then we made some editorial changes. So all the exchanges in the protocol, all the EAP conversation have this common part, kind of handshake. and we move that to a separate text section. Of course, anyone who implements the protocol would do this naturally in this order. So you do first the common part and then branch out to the different exchanges. And now the text follows more closely how we would expect people to implement it. And this previously caused some confusion with the implementers. Finally, another thing is related to roaming support. So the method allows the server to assign a realm to the peer, which the peer will then later use in future conversations for so that the requests can be routed over the AAA architecture to the correct server. And this is especially useful in cases like eduroam with roaming. There was a question about when should the peer start using the realm that it received. And the answer to that is now written in the text. It is that use it as early as possible, immediately start using the server assigned realm. That is because it makes the roaming more seamless in some specific scenarios. Okay, so those were the updates for this version. And there's the next slide already. We have analyzed these so-called misbinding threats against pairing protocols, and okay, the audio seems to be cutting off.
We can still
hear you can hear me. In the previous meeting in the SAR session, I gave a presentation on these misbinding attacks, and we have now published a full report at ACS-CCS, which is an academic security conference, and the report is available online. It explains the threats and the potential mitigations. This information is useful also for any other peering or device registration protocol where.
Excuse me, Tomas, quick question. The slide says March 2009. You're talking about the presentation at the last SAG, right, with the misbinding?
I don't know where that came from. It's 19.
It's not really old paper.
Yes. Okay. So I seem to have lost the video, but let's continue to the next slide. Next slide, please.
We're on the to-do list slide.
Oh, okay. I lost the video completely. Okay. So here is my to-do list, and we don't plan any major changes. I don't have any plans to make major changes to the specification anymore, unless there is someone else comes up with a reason. But there will be small polishing. So one thing is that the message examples need to be updated with the changes made to the version 6. And then I'm still a bit worried about the timeouts and the usability aspect related to timeouts. So we may need to do some modeling and user testing about that. And we have solved the problem of lost last messages, can recover from that, and we have formally verified that it works, but that should be written up and reported in some way, not in the draft, but somewhere else. And finally, we maybe should write into the draft these hooks for future extensions, which we have been thinking about along the way. So things that I already mentioned: device registration while roaming, identifier randomization, configuring application parameters. We are currently only creating a shared key for the application layer, but not really don't give any advice how to configure other parameters. And then maybe interplay with the manufacturer certificates and other credentials, which themselves are not always sufficient for authentication, but could help mitigate threats like misbinding. Okay, next slide. That should be the final summary slide. And so to summarize, EAP Noob is an EAP method for user-assisted out-of-band authentication, and the draft is now, I think, fairly complete and should be quite stable. We have implementations for Linux and new implementation of the peer on Contiki, ongoing work, and then formal models of the protocol and of the security aspects, the authentication. And there seems to be some interest in this protocol, the people asking questions, and this could be a work item related to the paragraph for rechartering that we just saw. Okay, thank you. That's all I had.
Any questions for Thomas? Okay, thank you. Next, we have Elliot up with Keep Brewski.
Good afternoon again. This is a very quick update. We've done a little bit of work on Keep Brewski in the text, but mostly been spending time coding. Doesn't seem to be advancing. Thank you. All right, so review RFC 7170 specifies TEEP. There's TLS-based authentication as well as some enrollment support. Some really nice TLVs in there, which essentially I would say mimic EST in some way, shape, or form. RFC 8366 specifies a voucher format in which to do trusted introduction. At least the results of that are the draft IETF Anima bootstrapping key infra says here's how you do the request to get the 8366 voucher, and this draft incorporates all three into a flow. Next slide. Okay, so I'm not going to go through how everything works because I've done that several times in this room before, and I want to respect your time. Here's what we did. The first thing is the last time you saw the draft in Prague, there were no security considerations. It's not that there aren't security considerations, it's just that we hadn't gotten to them yet. And I pleaded, prodded, poked, and otherwise convinced Dan Harkins to help us out on this, and he did. And filled in what I think is a pretty good claim section to begin with, the securities consideration section. So I'd ask you to please review that. Diagrams have been updated. The principal reason the diagrams have been updated is that we had to combine the join registrar and EAP server in order to satisfy the Anima Brewski and 8366 requirements, such that signatures all match along the path from and are well bound from all the way from the peer all the way out to the massa. The diagrams are not yet to my liking. We have a few ASCII humps in them, which I think I can remove just by splitting a couple of the diagrams into two and removing elements in various places which would otherwise be redundant, but that's very cosmetic. What's really needed now is just to do implementation, development, and testing. We started that just by testing out TEEP to make sure it works. So we are obviously finding some of the same ambiguities that Uni found. And so we're going through all those right now. Our next step is to go further. We're developing on both sides of this in terms of both a server implementation, and we're developing in the WPA supplicant code base as well. And we're doing a little bit of testing in host APD. To make sure that this will all work smoothly. So what we're hoping then, next slide, if I even have a next slide. Yeah, okay, good. Yeah, coding happening now. A couple of things that we're still thinking about along these lines is whether there are some 802.11 interactions. Here's the basic problem. So in order to get to the point where you're doing the TEEP transaction, what happens if you're in the middle of Tokyo and you have 2,000 VSS IDs that are blasting at you saying, join me, join me, join me. So you have the device has a choice. Can it hunt through all of those to go find something that it can join? It might take a very long time. In the meantime, its battery is going. And so that might mean that we might need to do a little bit of 802.11 integration. In some cases, it might not be 802.11 integration, it might be integration with Wi-Fi Alliance componentry or something like that, which is all based on 802.11. We haven't quite worked any of that out. But we're thinking about it, and that's really an optimization on the flow that you see in the draft. The draft basically makes various different portions of the exchange conditional based on whether or not you're able to use the authentication material that you have. So I will do a quick redraw of the diagrams to avoid the humps. Again, it's aesthetic. And then what I'm hoping for is adoption in time for Singapore, as we begin to see some code and produce some results. So that's the update. Questions, comments, thoughts, criticisms, tomatoes?
No tomatoes?
Bananas?
All right.
I was waiting for, well, no, yes, we have no banana.
Oh, wait.
Okay. I'll throw a hand grenade. Dan Harkins, could this voucher that Keith Bruschi used be considered an out-of-band mechanism?
Partly.
Is this a OOB?
It is. It partly could be. Let me give you an example of how it might be. So this ties into the Anima architecture. And so there are two possibilities in that architecture. One possibility is you go all the way out to the manufacturer and say, hey, is this yours? And if so, can I have a voucher, please? And that, I wouldn't call that out of band, I'd call that in band, even though we're not specifying the MASA communication. The second part is, instead of that, I've been given a voucher through whatever means I've been given it, right? And I've shoved it into my join registrar, right? At which point you've received this thing out of band, you shoved it into your join registrar. Maybe it's as simple as an Excel import, or hopefully something a little bit more structured. And then from that point, you could just as easily authenticate, so you don't have to do the cloud transaction immediately thereafter. And I'll give you another example of that flow, which is it could be that the sales integration that might happen as part of this, and you can see this with, say, some of the cloud-based IoT providers. This is where they're going. They may want to hand me a voucher at the time that the sale occurs, and I can just cram it into my AAA infrastructure right then and there. So there's no cloud transaction needed, but that should not affect the bits on the wire that we're specifying. I hope. That's what we have to test out over the coming months and so. Any other questions, comments, thoughts? Bye-bye.
Thank you. And last but not least, Owen.
Okay, so this is the third time I've given this presentation. I've given a variation of this at Acme and a variation of this at Anima. And what this covers is how we can use an Acme CA in the cloud, or it does not be in the cloud, an Acme CA as a backend for issuing certificates when you do an enrollment over TEEP. So the high-level summary is, TEEP specifies how a peer can perform a certain enrollment in band by exchanging PKCS 10 and 7 messages with the TEEP server. TEEP doesn't define how the TEEP server interacts with the CA. Acme defines how a client can interact with a CA and get certificates issued automatically. And what this draft covers, it covers multiple things, but the thing that's most relevant here is it shows how to stitch these two things together, how a client can interact with a TEEP server, exchange PKCS 10.7 messages with the TEEP server, and the TEEP server can turn around and talk to an Acme CA to get those certs issued. There's probably no changes required to Acme or TEEP, but possibly TEEP is underspecified. I want to talk about that a little bit. So there's multiple different use cases covered in the draft. The one that's important is 3 here, TEEP. When we presented this at Acme, we agreed that the Acme issuance of subdomain certs would be split out into a separate short draft. And what that really means is a client can interact with an Acme server and prove ownership of a domain, and then the Acme server can then issue multiple certs against subdomains without the client having to explicitly prove ownership of all the subdomains. So what that means for client integrations is that the client, which would be a TEEP server in this use case, would prove ownership of a domain once, and then that client would be able to get certs from Acme for multiple different client certs against subdomains of that primary domain. The use cases we've talked about EST and Brewski in Anima. We had a side meeting this morning, and there's strong interest in pursuing and progressing the EST and Brewski work, so that a client will be able to talk EST or a client will be able to talk Brewski to a server, and then that server can turn around and talk mapping to a CA to get a cert. That work will be progressed. But a logical extension of this as well is a client talks TEEP to a server, and that TEEP server turns around and talks Acme to a CA. Call flows here. This is just boilerplate stuff. This is lifted from my draft. It's standard Acme authorization stuff. It's straight from the Acme draft as well. And it simply illustrates how a server interacts with Acme and DNS to prove ownership of a domain. There's nothing new here. It's boilerplate Acme. What I'm showing here is, and it's a bit of an eye strain, but it's taken from this current draft. It's just standard boilerplate TLS 1.2 tunnel establishment using TEEP. Nothing new here at all. And this is the interesting thing here is once the TEEP tunnel is established and the client sends a PKCS10 TLV request in that TEEP tunnel to the TEEP server, we can see that the TEEP server is turning around and interacting with the Acme CA to get that certificate issued. There's a couple of things that are not fully specified here and we haven't really thought through properly. One is the mechanism by which the peer will definitively know what domain or what FQDN, what identifier to put in the subject or the SAN to keep Acme happy. And the other thing that EST covers, but this doesn't, is potentially when that PKC, and TEEP doesn't cover this either, when PKCS10 request is sent to the TEEP server, if the TEEP server wants to fulfill that request but is not able to fulfill that request yet, how does the TEEP server signal to the client that, yes, I am willing to give you a PKCS7 response, but not yet? So TEEP doesn't cover how to do that. And discussion, that's it. Really short presentation. Is this of broader interest? It is of interest to the EST and Brewski communities. It is of interest here. Is there a gap in existing TEEP? In existing TEEP, do we need some kind of back off or retry mechanism in response to a PKCS10 TLV? Are there any channel binding issues not covered by section 382 of TEEP? I'm not sure. I don't think there are, but I need to review that as well. There are some related drafts as well. There's a couple of related drafts here that REFAT has and Kathleen has for issuing Acme being used to issue device certs, but they don't explicitly touch on TEEP integration. That is it.
So, Owen, thanks for this. And it is really interesting because a lot of what small enterprises don't even want to run any form of CA, and the ability to maybe link up to a public CA or something like this is going to be very, very useful in a number of cases. The reason I got to the microphone is I think what you're asking about the TEEP work is, do we need to have the equivalent of a 202 response code in the draft that we put together? And I think the answer is yes, we do. I think one of the things that we need from the security area as we go through a lot of the review around this is what are our where is resource consumption occurring in the process of doing that? And the fundamental layer is that if the CA is unavailable at any given time, somebody's holding state, essentially saying, as we were saying in another room, no soup for you, come back in 5 minutes. But how does state expire in these circumstances? We should be studying that a little bit.
Thanks, Owen. Dan Harkins again. Perhaps this is in the related drafts that I didn't read yet, but how do you envision these devices or these certificates get named? So if the device is widget. My serial number is 1234. I guess that would be in the CSR, but then
that's exactly the open issue that I mentioned going through. One open issue is how do we ensure that the device, the station, knows exactly what FQDN or identifier to put in subject or SAN to keep Acme happy. And in EST and Brewski, the way that could happen is the device sends a CSR attributes request to the server, and the server responds and tells it what to put in the subject. How it works here, it's an open item. Do not know.
Okay, thanks.
Okay, Joe Salloway. So it's kind of interesting to have that the kind of, I can't give you a certificate now, come back later. I mean, the net result there is probably you're going to not get any network. I mean, I think it actually could work that you basically reject, you do an EAP fail and give the person a token to call back later with, and this state could all be maintained probably in the back end.
You could even work that with TLS 103 session resumption, right? So you give it a token to retry, establish a new TLS session later, or
yeah, you would still probably need the. Does Acme support the call me back later?
Yeah, it does.
And so there's probably some token that the client would have to maintain, but the Acme would be maintaining the state on whether the cert was, on how to get the cert back. So I think it would be possible. You're not going to have any network connectivity until that point, which may or may not be a problem.
Yeah.
Mohit. So two questions or remarks. Anything that happens beyond the TEEP server is not really concern of this group, whether you use Acme or FooBar, right? Whatever happens between the EAP peer and the EAP server is what EAP is doing. And I mean, sure, you could use Acme. I'm not an Acme expert, but I don't know whether Acme does client certificates or does it even distinguish between client certificates and server certificates, because my understanding was Acme was mostly for like domain validation and server certificates and not for issuing device certificates. Maybe there is some new work there.
So we have use cases where the thing that's getting the certificate is both a client and a server. So we have like
sure, but this is not the group to do that, right? Maybe Acme is the group to do that.
So there may be there's a couple of things here, right? First, there may be work required in the PKCS10, PKCS7 back-off retry. There may also be work. The question that Dan asked and the open question I raised as well is the mechanism by which the station or the peer knows exactly which the CSR request it generates. Possibly that might require
But it involves changes to the state machine that TEEP goes through in order to enable that. Okay, the TEEP client and server, okay, the supplicant and the authenticator, okay, have to add states to deal with this additional question. Acme already deals with the problem. It's already stated, do something. The point is, that's why we're here discussing it, is because it involves changes, potential changes to the state machine of TEEP, okay? And Acme doesn't know anything about that. You do, right?
So yeah, maybe there is something we can look into that. The second kind of note I wanted to make, it should not be the device or the peer that says, issue me this certificate. It should be the TEEP server which is authenticating the peer, saying that. So the server is the one that sees this is the device that's trying to connect to me. This is the NIE that it sent to me, and whether I issue it a certificate for the NIE that it sent me or for something completely different, it should be the server that enforces this, and not like client saying, hey, can you give me a certificate for that guy in the next room?
But it is the client that generates the CSR, and it's the client that sends a certificate request to the server. The server turns around and enforces the policy and decides how it's going to interact with the CA. But it's the client that generates the CSR, and the client needs to know what identifiers from the C score.
Okay, so you're saying that the server would still enforce it when it sees the CSR, but okay.
Yeah, the server can enforce a policy, but it, the client has to generate the request. Okay. Thanks. Any other questions on this topic? All right, now I think we've run through our regular agenda. I don't know if Bernard, if you ever got to cover the topic you wanted to cover at the beginning when we missed you. Or if anybody has another topic. Up, here comes Bernard.
Yeah, basically I've been working offline to get Alan the contacts he wanted, and I think I may have that. So that was my only comment relating to Alan's questions.
Okay. Great. Thank you very much. Roman?
Roman Danelio, I'm just bringing up a pet topic that I'm sharing in all the working groups. I love the fact that we're talking about kind of drafts, and I love the fact that we're saying, let's wait for the code to help us. I think that tremendously improves kind of the quality. One thing I would ask this working group is, can we put a list of those implementations relative to those drafts somewhere where it's easily accessible, perhaps not to those that regularly come to these meetings, so there's a better sense of what the running code is behind those drafts. So working groups like TLS, DOTS, and others have done things like that. Do it in GitHub, do it in the track wiki. I would recommend not just the list. I would recommend, running code versus this draft and potentially even which version of that draft. And that'll help if we decide to do interop testing. And it certainly helps me when I advance drafts to say it's not just us having written some words. It's we have some code backing us to give us confidence to progress the drafts.
Great. Thanks.
So I think, let me check. RFC 7942 even says that the drafts should include a section on implementation status. So the drafts themselves also have, but I agree that having a wiki for the working group for all the different drafts and their implementation status would help.
Cookies.
Yeah. Dan.
Other business?
Other business, Dan. What is it? Aside from cookies?
Yeah, well, cookies in a minute. I sent a note to the list. I have a new draft out that fixes the attacks against EPWD that were highlighted in the Dragon Blood paper. So please have a look, comment, and thank you.
All right.
Thank you.
Bernard, did you have another? No, I think he didn't leave the queue. All right. See you next time. Oh, wait, Bernard, are you?
Yeah, I just had a question about whether we were thinking about interop tests for some of the TLS 1.3 stuff at some point.
Interop tests?
Yeah, like at a hackathon in a future IETF.
I think that's something we'll have to take up and see if we can find it, but I think that would be a good idea.
Okay, thanks.
Yep. Yeah, interop would be nice. Everybody sign the blue sheet. Hey. Hey, Alan, you heading back now? I'm heading back in an hour. Some of like your triple is not just forget about using it as a string yeah. Will be notified here. Yeah.
I mean, CVM that's was really awesome, but we got debated like
Dinner very early.
That's why you were like by 9 o'clock you were it will be too late for you. So I was like, okay, I'm not going to we left at like 8:20 or something.
Right.
In that case, maybe we if the customer is customer, they don't have their privacy, so but if they have the privacy, usually